In section 3.4, we have the introduction to the chain rule. So in algebra, as I'm going to read, you learn about composition of two functions, f and g. And this is where what we did in chapter 1 comes into play, because I was asking you guys in chapter 1 about the inside function and then the outside function. And you guys had like a big function, you were taking out the inside piece and the outside piece and turning it into one another. So you were going into composition of function, then out of composition of function with the inner and the outer piece. So we've just got a couple examples of what you've seen. So if we have f of x, then g of x, if I want f of g of x, plug g into f. Same thing with sine and x cubed. If I want f of g of x, plug x cubed into x. And then if we have g of x equals cosine x, and then f of x equals x cubed, I plug g into x cubed. Another way of writing cosine of x, entire quantity cubed, is cosine cubed x. So this is another way of saying the exact same thing, and most of the time you're going to see cosine cubed x. So in calculus, you're going to have to take the derivative of composition of functions, and that is called the chain rule. So with the chain rule, you're going to have to think about the inner and then the outer. So to start with, you're going to take the derivative of the outside piece. So we've got f prime, and then you're going to leave the inside exactly how it is. So I'm going to leave it as, in this case, g of x. And then after that, you're going to multiply by the derivative of the inside piece, which is then g prime of x. So you're going to take the derivative of the outside multiplied by the derivative of the inside. And that is how you're going to work with chain rule, all right? Composition of functions. So in problem numbers 1 and 2, we're going to be given this graph along with their derivatives in this table. So it says, given h of x equals f of g of x, find h prime of 2. So to find h prime of x is what you're going to have to do to start with. At the very end, you plug in the numerical values. So do not plug that in at the beginning. The outside right here, it says f. So you're going to take the derivative of f, and inside you're going to leave it exactly as it says, and then you get to multiply by the derivative of the inside. So it's derivative of the outside multiplied by the derivative of the inside. From here, now you get to input the value of 2. So now we have h prime of 2. So we've got f prime of g of 2, and then we've got g prime of 2. And we're going to go ahead and read the table. Just like composition of functions, you're going to make sure that you find g of 2 first. So you're going to go to when x is 2 and then go over to where g is. So now we've got f prime of 3. So we're changing g of 2 into 3. And then we've got g prime of 2. Well, g prime of 2, it looks like, is 3/2. So I can go ahead and fill this in with 3 over 2. So our final answer, let's see. We've got f prime of 3. So we're going to go to when x is 3 and go to f prime. So we've got -1. So we've got -1 multiplied by 3/2 gets us -3/2. In problem number 2, we've got j of x equals g of f of x, and we need to find j prime of 1. So once again, do not plug in the numerical value until the very, very end. So let's start with j prime of x equals. So you're going to take the derivative of the outside. So we've got g prime, and then you write the inside exactly as is. And then you're going to multiply by the derivative of the inside. So from here, we can then input 1. So you've got j prime of 1 equals g prime of f of 1 times f prime of 1. And we're going to go ahead and read the table. So we've got g prime, and we're going to input f of 1. So we have to find f of 1. Here's 1. F of 1 would be 5. So I get to replace 5 right there. And then we've got f prime of 1. So we've got, again, 1 right there. The derivative is -1. So we're going to go ahead and replace that with -1. And then let's see, we've got g prime of 5. So 5, g prime is -1/2. So -1/2 multiplied by -1 gets us our final answer of +1/2. All right. With number 3 and 4, in number 3, I just have to find the derivative, and then number 4, it asks us to evaluate the derivative at x equals 1. So both of these are involving chain rule. Now it says and power rule because the outside is the 5. The 5 is the exponent. So that's where the power rule comes in. So you're going to take the derivative of the outside. So I'm going to write down dy over dx equals. We're going to take the derivative of the outside. When I take the derivative of the outside, I multiply the 5 into the front, subtract 1, and we get 4. The inside stays exactly the same. And then we have to multiply by the derivative of the inside. So the derivative of the inside is going to be 3x squared plus 1. And this is your final answer. And then you leave it. You don't have to do anything else. In question number 4, we're going to find the derivative. Again, using the power rule, just because there's an exponent right there on the outside. So take the 2 and multiply to the front, and then you subtract 1. When I subtract 1, we get 1, which you don't have to put it. The inside stays exactly the same. So we've got 3x squared plus 1. That's the inside. And now you're going to multiply by the derivative of the inside. So we've got times 6x. Next, we're going to evaluate at x equals 1 for a final answer of 48. All right. In question number 5, it's the same thing, except for we're going to evaluate it at 2. So let's go ahead and find the derivative first. We've got h prime of x equals. Now, with power rule, you're still multiplying that into the front. So we've got 3 over 4. The inside stays exactly the same, x squared minus 4. And then you're still subtracting 1. When you subtract 1, it would be a lot easier to subtract 4 over 4 so that you get 3 minus 4, which is negative 1 over 4. And then don't forget to multiply by the inside, the derivative of the inside. The derivative of this inside is going to be 2x. Now, when we take the derivative of the 1, we get 0. So this is our derivative. We are evaluating it at 2. So we can go ahead and input the 2. As we're doing this, keep in mind it's 3 times 2, which is then 6. And then I'm filling in the x with the 2 divided by it's 4, and then it's the 4th root of 2 squared minus 4, which means that we've got 12 divided by, that's 0, the 4th root is 0, times 4, which is 0. 12 divided by 0, that's going to be undefined. So the slope is essentially undefined. So at this value of x being 2, the instantaneous rate of change is undefined because the slope is a vertical line. Okay, so you've got a vertical slope right there. I went ahead and changed the answer to undefined, letter E. Change that on mine. Yours might say D and E. Just make sure that you change that to undefined. The slope is undefined. Okay, that is the basic gist of it, of what we're doing with chain rule involving power rule. And from here on out, we're just going to go through this page. It's going to take us through all the important derivatives. So we're going to start with chain rule involving exponentials. So when we've got chain rule involving exponentials, you're going to treat it the same. Now the inside piece is going to be that 3x. So we're going to take the derivative of the outside. And when we take the derivative of exponentials, it's a rewrite times natural log of the base number. And then the inside is this 3x. So we're going to multiply by the derivative of 3x, which is 3. Now nothing can be multiplied together. You cannot combine anything else. If anything, you can move the 3 to the front, which then goes to the exponent, but I would just leave everything as is. So this is all being multiplied together. Number 7, let's do it again. dy over dx equals, we've got a rewrite. Natural log of the base is e, natural log of e, and then multiplied by the derivative of the exponent right here, which the exponent right there, the derivative is just 3. And the only thing that I'm going to do is say that natural log of e equals 1. So essentially our final answer is going to be 3e to the 3x. So it's the derivative of the outside, so it's a rewrite, natural log of the base, and then multiplied by the derivative of the outside. In number 8, we've got h of x equals e to the power of natural log x. If you think back to chapter 1, natural log has a base of e. The bases are the same, so really h of x just equals x. That's actually what the function is. H of x equals x. And then we could take the derivative of that, and that's not chain rule at all. The derivative of x is just 1. So it might look like chain rule, but it is not. Number 9, this looks like power rule with chain rule because we've got a power right there. We might have some chain rule going on with the inside piece, but then it's also product rule because these are being multiplied put together. Well, since e's are the same base, you can go ahead and combine the exponents as one of your rules when you have the same base. So it's really e to the power of x squared minus x. So when we take the derivative, and again, do not get messed up with the different ways to write the derivative notation. You could put dy over dx or y prime. So we're going to take the derivative of the outside, so it's a rewrite. Natural log of e, which is just 1. And then you multiply by the derivative of the exponent. So we've got 2x minus 1 as our final answer. Number 10, we've got y equals cosine of e to the power of x. And cosine has to be next to, or has to have something inside of it. Otherwise, cosine of whatever is just a number. So cosine of e is a number, but cosine e to the x, that is not a number. So it would be product rule if this read y equals cosine x e to the x, then that would be product rule. But this right here is actually chain rule with the inside being this right here. That's my inside. So we've got the derivative of the outside. The derivative of cosine is negative sine, and then it's a rewrite. And then we multiply by the derivative of the inside. The derivative of e to the x is just e to the x. So really our answer is negative e to the x sine of e to the x. So this is read the original y equals cosine of e to the x, and my derivative is then right here. All right, number 11, just follow the rules. We've got f prime of x equals, it's always a rewrite, natural log of the base multiplied by the derivative of the exponent. In this case, our exponent would be the derivative 6x. And this is our final answer. And you can leave your answer just as is. For the next couple of problems, we've got chain rule involving natural log. So chain rule involving natural log is really similar to what we've already done. So it's going to be 1 over, and then you're always going to rewrite that. So 1 over 7x. And then what you're going to do is you're going to multiply by the derivative of this. You'll notice that the 7's cancel out, so you're left with really just 1 over x. Number 13, we've got the derivative of g. So you're going to start with 1 over, and then you're going to start with a rewrite. It's a rewrite of this. 2x squared plus 3. Then you're going to multiply by the derivative of what's inside natural log, which is 4x. The only thing that you could possibly do is combine it into a singular fraction, and that is it. Number 14, let's start with a rewrite of what's next to natural log. So we're going to rewrite this, and then we're going to multiply by the derivative of that. So we multiply by 4x cubed. Right here, I can cancel out all of the 3's, and then so I've got just 1x left over, so we've got 4 over x. That's our final answer. And after this, number 15 is written a little bit differently, but it still is involving chain rule. So we've got the derivative of the outside, ln x, and then subtract 1, multiplied by the derivative of the inside. Derivative ln x is just 1 over x. We'll keep going in the next video.